All right, Math 2, here we go. We got lesson 1.2.3, areas as a product and as a sum. So we're going to be looking at how can we write the area and as a product and as a sum, but what we're going to start with is looking at perimeter and area. So here, this one says that this area is x. So we're going to say that this length is x and this length right here is 1. So if this is x and this is 1 times x, that's how this is x. So this is 1 times x, so this one's x. This is 1 times x, so the area of that one's x. Now this one is going to be x times x. So the area of this entire shape, x times x, would be x squared. And then these are all unit squares, which means it's the outside of it's 1. So the outside of that's 1, 1. So this is a unit square of 1, unit square of 1, unit square of 1. All right, so first thing we're going to look at is the area. That's the easiest part of this. With the area, all we have to do is add up all the areas of the smaller shapes. I've got 1 x squared area. That's the area right here. So for my area, I'm going to say I have an x squared. There's one of them. I could write the 1 in front, but I'm not going to. I'm just going to write x squared. That means there's one of them. I've got 3 areas that are x's. So 1, 2, 3 x's right there. So I'm going to say I've got 3 x's. And then I've got 3 unit squares here. 1, 2, 3. So there's 3 of those. And there's my area. X squared, this area, plus these areas, 3 x's. And then plus these 3 areas, those unit squares. All right, now this is where it gets a little bit harder. So we want to find the perimeter. We want to know if we add up all the sides, what is the perimeter going to be? So this side right here, from here to here, that side right there has a distance of x, right? Because this side here had a 1, a 1, a 1, because it's 1 times x is x. So that's a length of x right there. This from, let's see, from here to here is x. So let's go up here. Let's do this one first. So this one, if I look at that side, I've got an x right here plus a 1, a 1, a 1, a 1, a 1. So that's 5. So x plus 5. That's the length of that side up there. So I've got this one's x plus 5. All right, moving on. Let's look at this side here. This side here is this part right here is x. And then I've got 1, 2, 3 right there. So that's x plus 3. Okay, now I got to deal with these other parts. Let's say this part here, that's a 1. This part here is a 1. I've almost made it all around my shape, except now I've got, let's see in green right here, I've got this part, and then this part right here. Now you might be looking at going, oh, it's 3 because 1 plus 1 plus 1. But we don't know that's a 1 right there. So what we can do is we can look up those 3 green parts and say, okay, if these 3 are put together, they would be the same length as this side over here. Right? Because this side, and then this side that's unknowing, not unknowing, this part that's unknown right here, would be equal to all of this. So this side over here, these 3 parts, is also x. So for my perimeter, I can just add up all my parts. For my perimeter, I've got, let's see, for the perimeter, I've got x plus 5 up here. For over here, I've got x. For over here on this side, I've got x plus 3 plus this one plus this one. So it's actually x plus 5 for this one, and this one. So x plus 3 plus 1 plus 1. That's x plus 5 again. And then over here, we said that these three together make x, so plus x. So we can simplify this by combining our like terms. And I've got 1, 2, 3, 4 x's. So our perimeter is 4x. And then 5 plus 5 plus 10 over here. And there's our perimeter. All right, let's look at this one. Since this is a y right here, this is a 1 and a y, the area of this section should be y times y. So this will be y squared in there for the area. This one's just like this one. So these are both x squareds. And these must be unit squares right here. They're both 1s. All right, so let's write down the area first because the area is a little bit easier to do. The area for this, I've got 2 of the x squareds. So I'm going to write 2x squared. I've got 1 of the y squareds, so plus y squared. I've got 1 of the y's. And I've got 2 of the unit squares, so plus 2. And there's my area. All right, so now we're going to look at the perimeter. So up top, that's probably the easiest place to start. From here all the way over to here, that section in there, this section is y, because remember this is y times y, and then these two sections are both x's, because they're x by x. So this would be 1 of the y's and 2 x's. So that's the length up there. From here down to here, we've got a y right there, and then we've got 1, 2. Because this is 1 times y over here, so this is a 1. So 1, 2, so this would be y plus 2 from here down to all the way down to here. Okay, down here, this section, this section, this section, this section, and this section all add up to this one up here. These three are y together, and there's an x and an x. So all of that up there is also y plus 2x. You notice over here it was x and x, and then x plus 5, x plus 5. It's going to be the same thing on this one. So if I'm looking at my last side, this side, this side, this side, and this side, all of those together should be the same as this part right here. So that's going to be y plus 2 on that side. So from here down to here, that's going to be y plus 2. That wasn't very good. So my perimeter, I've got, let's see, how many x's do I got? I got 1, 2, 3, 4 x's. And I've got, let's see, how many y's? 1, 2, 3, 4 y's. And then I've got 1, 2, 3, 4, plus 4. All right, so now for the real stuff. So we're going to be looking at rectangles, and we're going to find the rectangles as a product and as a sum, so them added together. So sum is the easiest one. It's similar to what we were doing up here. So let's look at this. If I write it as a sum, I've got 1x squared. I've got 1, 2, 3, 4, 5, 6, 7 x's. And I've got 1, 2, 3, 4, 5, 6 unit squares, so plus 6. That is the area written as a sum, where we're just adding up all the different parts. Okay, the other way that we can write this is as a product. What we mean by product is in a rectangle, remember you do length times width. So if I can find this length and this width, I can write them as being multiplied by each other, and then that would be another way to write the area. So here, this is x, and this is 1 right here. So that side is x plus 1. Over here, this side is x, because remember it's x squared, so x times x, and these are all unit squares here. So this is x, and then 1, 2, 3, 4, 5, 6 unit squares. So this would be x plus 6. So the way that we could write this as a product is that could be written as x plus 1 times x plus 6. And what we're saying here is that these are exactly the same. X plus 1 times x plus 6 is x squared plus 7x plus 6. They're the same exact thing. Just one is written as a sum, and this is written as a product, as you multiplying two binomials together. All right, moving on. For each expression below, build a rectangle using algebra tiles and sketch your tiles. We don't have algebra tiles, but this is basically what I would do. I'll just do it really quick. Here's my x squared. I need one of those. I need 8 x's, and I need 12 singles. So I have to decide how I'm going to build that, having 8 x's and 12 singles. I'm going to draw it out. I'm going to pause it, draw it out, and then show you how I did that. Just a second. All right, so yeah, it's late in the day. I want to go home, so this isn't done very nicely, but you get the point. So I've got an x squared here. I put 2 of the x's here and 6 of them here so that I have 8 x's. Why did I do 2 and 6 instead of like 4 and 4 or something like that? Well, I know if I had 2 times 6, I would get 12. So I needed to set up these x's so that when I make my unit squares here in this section, that I get 12 of the unit squares. So I was thinking, okay, if I put 2 of the x's here and 6 of the x's here, that would, a 2 by 6 is going to be 12 right there. And so that sets that up. All right, we're going to do the next one. I'm just going to pause it and then show you how it did so we don't waste your time. All right, and there it is. So I put my 4 x squareds, oh goodness, all like this in a box kind of. And then I've got 1, 2, 3, 4 x's there. You want to keep this as a rectangle. So what I'm saying here is, since this side over here is x plus 2, and this side over here is x plus 1, 2, 3, 4, 5, 6, that x plus 6 times x plus 2 is x squared plus 8x plus 12. And over here, this is x and x, so that's 2x on that side. Over here, it's x, x, 1, 1, so this would be 2x plus 2. So what I'm saying on this one is if I multiply 2x times 2x plus 2, I should get 4x squared plus 4x. There's a couple other ways you could have done that one, but that's just the way I chose to do it. All right, one last thing. Oh, no, we got a back page, sorry. All right, so write it as an area, as a product, and sum. So let's start with the product. So this side here, that wasn't very good. So I've got x, x, x. I've got 3 x's, and I've got 1, 2 unit squares right here. On this side down here, oh, I'm getting messy at the end of the day. All right, I got x, x. I've got 2 x's, and I've got 1, 2, 3 units. So as a product, oh, you can't even see that. Jeez. All right, so as a product, I've got 3x plus 2 times 2x plus 3. Because this is a rectangle, and we're just doing length times width. So that's one way to write the area, as length times width equals the area. The other way is to write it as a sum. A sum would just mean me adding up all these little areas inside of there. Let's see how many x squareds I have. 1, 2, 3, 4, 5, 6. I got 6 of the x squareds. How many of the x's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I got 13 of the x, not 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I do have 13. I have 13 of those x's. And then what do I have left over here? 1, 2, 3, 4, 5, 6. I've got 6 more. So these are both ways to show the area. This is how you can show the area as a product, two things being multiplied. This is how you can show the area as a sum. All right, back page, almost done. Okay, so we've got an area model puzzle here. So what I've got is, this is 3x squared. So you can kind of think of it as being 3 of the x squareds. We're just kind of condensing everything, putting it together. And then over here I've got 6x. Well, what I want is I want the length times the width to be equal to that. So since this is x, what would I multiply x by to get 3x squared? Well, I would multiply x by 3x. Okay, now on this section, if this is 6x and this is 3x, I'm just looking at this little section here. If the area is 6x and this is 3x, what do I multiply 3x by to get 6x? 2. So now I know that x plus 2, that's this side here, times 3x should be, oh, stupid lights! There you go. I had to move because the lights turn off if I don't move enough. All right, so this is just saying that x plus 2 times 3x is equal to 3x squared plus 6x. So basically, on these puzzles, I'm writing them as products and squares. Products and sums. Oh, end of the day. All right, now let's do this one. I've got x squared down here, and this part is x. So x times what is x squared? This has to be x. Okay, now since this is 1 and this is x, 1 times x here, x times 1, this should be 1x, or just x. Okay, this is x, and this is x. So what do I multiply by x by to get x? I multiply it by 1. And then this last box here, this is 1, and this is 1. So 1 times 1 is 1. So writing this as a product and sum, I can now say that x plus 1, that's this side here, and x plus 1, that side there, is equal to the sum of the areas. That would be x squared, and then 2 of the x's plus 1. All right, let's work out this puzzle. So this one, let's see where we're going to start. Let's see. Okay, so 2 times 3y. So that's this section's 2, this section's 3y. This part has to be 6y. So I get that one filled in. Next one, let's work it here. 2 times something is negative 4x. This has to be negative 2x. Only way to do that. Okay, let's work over here. 2 times something is negative 10. That must be negative 5 right there. All right, now I need to find out this side here. So 3y times something is 3xy. Well, this must be x, because x times 3y is 3xy. And now I can fill out these last boxes, because this box is going to be x times negative 2x. That's negative 2x squared. And this one over here is going to be x times negative 5. That's going to be negative 5x. So I can write it as a product, x plus 2, times this stuff, negative 2x plus 3y minus 5. So that's written as a product. Or I can write it as a sum where I just combine all the like terms. So here's my x squared term. It looks like I only have one of the xy terms, so I'm going to put plus 3xy. I've got two different x to the first term, so I can combine those two like terms. Combining those two, negative 5x and negative 4x makes negative 9x. And then I've got a 6y minus 10. So these are the same two ways to write the area of that part there, or that rectangle there. So this is written as a product where I just do length times width. And this is as a sum where I'm combining all my like terms inside. All right, last one, we're almost done. So this is 4x squared and this is 2x. So what times 2x is 4x squared? It must be 2x. This is 2x and this is 3. So 2x times 3 would be 6x here. And then on the last, oh, we still have two more. So this is negative 9 and this is 3. 3 times what is negative 9? 3 times negative 3 is negative 9. And now I can finish it off and do negative 3 times 2x and get negative 6x right here. So I can write it as a product. So 2x minus 3. And then 2x plus 3. So there I've written it as a product, length times width, and I can also write it as a sum. So as a sum, I've got 4x squared, that's the only x squared term, so 4x squared. I've got two x terms, but they cancel each other out. Negative 6x plus 6x is 0. They go away, and so I just get minus 9. So we're saying here that 2x minus 3 times 2x plus 3 is 4x squared minus 9. That's all we got for you. Math hard. See you guys later. Bye-bye.